Assalamualaikum warahmatullahi wabarakatuh, everybody. Welcome to a new video, and today we'll be dealing with the network layer. And as the network layer starts, there is actually one thing to discuss over here, which is IP address. IP addressing. The protocol for network layer, as you may remember, is IP, and the PDU unit is packets. So we'll start this and we'll go through IP addressing. So network layer does the transfer from host to host. So as you know that, so there's not much to describe about how it's used. Rather, the addressing is the point over here. So it is separate in both TCP and IP and OSI model, as you may know. Transport and network layer are completely different, and they have their own places in both models. So IP4 addressing, version 4 addressing structure. Well, there's also an IP version 6, and we'll be dealing with 4 here. And as you can see over here, let me use my weird pen and my Hebrew handwriting, of course. This part is the address, and every dot represents 8 bits. So 8 over here, 8 over here, 8 over here, 8 over here, 256. So that's the basic of IP structure. Let's move forward to the main stuff. As you can see over here, and we can do it in binary as well. So you will learn this down. We're just going through the topics we'll be discussing. And every single IP address has two parts. One is for network, one is for network, yes, I was right. One is for network, another is for host. How can I forget that? And if we can determine the network address, host address, broadcast address, all of these things using these binary digits, how we'll show you. And as you can see, let me just give you a little introduction, which is very easy. Generally, the network addresses have 0 in the end. And if it was class A, class B, you probably don't know those. Let's pretend that you don't know. So classful addressing is a matter, but the fact remains that it starts with 0, and they're generally the network address. And as you go from 0 to 255, there will be host addresses, so which is denoted by over the 1 over here, except that you can see that everything is same over here, 192.168.10. Okay. So this is important to know. 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, 4, 5, 6. So you will use this. This is a very efficient way to get the binary. You have this table, and you can convert any address to binary very quickly. So if you want to get 245, you would be wise to add 128, 64, 32, 16, and don't add 8. Don't add 2, and by adding this, subtracting this 9, you can get 245. How's that? That means your binary would be 1 1 1 1. I didn't use this, so it will be 0, and then 1 again. I didn't use this, so 0, and then 1. As you can see, the binary over here. That's the primary addressing style for IP address 4 and 6 as well. So 6 has a different structure, completely different thing. We'll discuss about 6 later. For now, we're discussing about IP4. Okay, so what do we have here? Look at this. It has been divided into 32 bits into 4 octets. Okay, and this is the binary version. So let's pick one. Let's pick this. As you can see, each of them has been divided. Starting from the left, you remembered that table I gave you in the last slide, 128, 64, 32, 16, 8, 4, 2, 1. You use that and multiply, and you get the number. So over here it would be 172, 16, 4, 20. Using this 16 and 4, using just the 4, and over here just the 16. So that's how you do it. Who's crying? Ignore that, guys. So, and then you have this network portion, as I mentioned. Okay, let me show you something here. So if you have this network address of 1, you will have 1, 2, 3 hosts. Maybe the person 2 has 2 hosts and the person 3 has 2 hosts. So one network address, multiple hosts. One network address, multiple hosts. This has one host though. That's the primary idea. Now the network portion is divided as equal to classes. It is actually divided based on classes. We didn't do classes yet. For now, let's just see this. For this, you have 3 portions for the network address. So as you can see over here, as it goes, the host number is increasing. There's a host who's at 2. There's a host who could be 68. There's a host who could be 205. Why am I adding 1? Because it starts from 0. And the 0 is the network user, so the host starts from 1. You can count that there are 204 hosts, 67 hosts, 2 hosts, and the one with the 0 is not a host, that's actually the network address. So moving on, host portion, as it's better to discuss this about after we get the classful addressing, so we'll get there. And then, oh, I'm getting very popular in Messenger these days, I don't know why. So let's start. You have an address over here, okay, 192.168.10.2, and you can see that 2 is colored blue. Why do you know that? It's because 2 is not a part of the network address, the rest is. And what is this 24? Let me clear it for you. /24, what part is this? This is called CIDR. We'll do this in details later, but for now let me tell you what this is. You can easily determine this using this table, 128, 64. Just imagine I'm writing those 32, 16, 8, 4, 2, 1. So for 24 you need 1, 2, 3, 4, 5, 6, 7, 8. For each set you will get 8, and 8 into 3 you will get 24. So this, and this, 8 into 8 into 8, that's 24. That means this whole part is my prefix mask, okay, the network portion. That's an easy way to determine the network portion. Well, still it will become a whole lot easier when we do classful addressing, and this is called subnet mask. What on earth is this? Remember we used 8 over there, 8, 8, 8, 0. So the subnet version suggests 8 is the limit, right? You can never have 9 bits over there. You can never have 9 bits. So 8 is your limit. So, and it goes up to 2 to the power 8, which is 256. And if you count from 0, it's 255. Right? So the subnet mask gives the idea, okay, we are using whole 8 over here. So 2 to the power 8, 256 minus 1, 255, because it starts from 0. Similarly for here, because we had 3 8s over there. Now if I give you an address like this, something 192, 23, 41, and I give you the CIDR of 16, then you have 8 into 2. That means only this part and this part. That means the subnet mask would be 255.255.0.0. Ta-da! That's how you do this. Okay. Oh, as you can see over here, 16 would give 2 and 8 would give 1, and there could be partial as well. We'll do that. For example, what would be for this 12? Notice this. Let me show you what will this be. Okay, we have 224 over here. Now how do you get to 224? You can add 128. you can add 64. That gives you how much? 188 plus 4, 192, which still even reach 224. So use 32. 190. I think now we have 224, right? 128 plus 64 plus 32 gives you a perfect value of 224. So in this part we will have 8 plus 8 plus 1, 2, 3. So 3. 8, 2 gives you 16 plus 3, 17, 18, 19. So the CIDR would be 10, 24, 36, 2, and CIDR would be 19. Dot, dot, dot. That's how you find out the CIDR. And in the reverse way, using the table 128 to 0, using that table you can find out the value of these, and that will give you the subnet mask. So that's how it's done. Moving on, we still have to discuss classes, and there are pretty more examples. You can try them yourself. As for here, it would be 0, 0, 0 over here, and there would be 254, so only one missing, so 7. Okay, now we will use AND for finding the network address a bit later. So as you know that AND of 0 and 0 gives 0, 1 and 0 gives 0, 1 and 1 gives 1, and 0 and 1 also gives 0. If you are studying network in computer science, you probably know what AND is by now, so let's not spend time there. So you have this IP address which is 135.15.2 and 1, and you have this subnet mask which is 255.255. Now the IP address binary is this, okay, and you also have the subnet mask, and if you convert this into binary, then we get 1111111 for this. Again 1111111, and all the others are 0, dot 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 0. So if you AND out this, then 1 and 1 gives you 1, 1 and 0 gives you 0, 0, 0, 0. Okay, we don't have to do this. All these zeros will give you 0, so there are 4, so we have 4 zeros, and these ones will give you 1s. So the same thing for this, all these 4 zeros will give you 4 zeros, and 4 ones will give you 4 ones, and all this, no matter what over here, what is over here, it will give you 0 for down for this address. So as you can see, your network address will turn out to be, ta-da, 135.15.0.0. If you binary these out, then you will get it. And doing the AND of this, this is how you get the network address from an IP address and the subnet mask. We already know how to get the subnet mask, and you also know how to get the binary of the IP address, which is very easy. And so host and subnet gives you the network addresses, and then you convert the binary back to the original one, and you will get the address. Okay, reasons to use AND. Routers use the ANDing process. Okay, this is not important. 3 types of address. Okay, I told you before, you already know about network address and host address. The last one is the broadcast address. This you don't know. So that one with .255 at the end of the host is reserved for broadcasting, because you need one address to send out data or receive data. So broadcast, the name gives you the function of the address. So that's another address, which is generally the .255, and the first one is the network address, and everything between is the host addresses actually. There you have it. So actually the host address of any IP address would be the host minus 2, because 1 for network and 1 for host, sorry, 1 for broadcast. As you can see, a network address over here, which is the first address, a broadcast address which is the last, and everything between is a host address. So up to 12254 you will get unique addresses which will be used for host address. Now network prefix is not fixed, as I told you that it could be partial sometimes, and then it's not necessary that you will always get a 0 as network address. I told you before. So network addresses turn out to be 0 most of the times, and in that network address you can have multiple broadcast and host ranges. That is called subnetting, will do that. And calculating network host and broadcast addresses, if you have any pair of those, you can find out the rest. I already showed you this, so let's not spend time over here. Unicast and address to one host, which is, you can say, unique IP addressing. Multicast, it could be a group of hosts. And broadcast, you already know what that is. Okay, so something that we need to do now, there's a concept of public and private addressing. So we will have a few addresses which are private. That means they could be private, and this address could exist at different places in the world at the same time and still be unique IP addresses. So those addresses are from 10 to the range of 10 with a CIDR of 8. So many hosts over here. 172.16, you will have this, which is very common. You may have it in your university or high school, with the CIDR of 20. Gives you pretty much a lot of hosts over here as well, and a very limited number of hosts on 192.168. So you have this and a CIDR of 24. I'm talking in case of BRAC University. If you're in BRAC University, you can detect these two private addresses. You already have those. For TSR, you use 172.16.2.1 something, 2.11, which falls under this. Okay, so that's private for BRAC. And then again, you have the proxy 192.168.0.1.5, which is the proxy address for BRAC U students. That is also a private, which falls under these two. You see? So we are already using this, but North, South and other universities can have the same addresses, but still their link will be different. That's what private IP address is all about, having it privately. Okay, that's all. And public IP addresses are routed over the internet, and it is internet assigned numbers authority, they hold it, and you would get it. It has registries and stuff like that. Network address translation: a large number of hosts on a network use private addresses to communicate with each other. So NAT is that allows to publics to share addresses when they want to use the internet. So let's see what. Finally, the classful addressing. You have class A, where you start from 1 and end at 127. You have class B, which starts from 128 and ends at 191.0.255 at the end. You have class C that starts from 192 and ends at 223. D and E. So, as you can see, for class A, there is 1 for network and 3 for host. For class B, 2 for network, 2 for host. For class C, 3 for network, 1 for host. And these are other addresses. These are not used for networks. So, the subnet mask would be like this for classes. Okay? So, let's move on and have some experiments. Okay. So if we put to the test, for example, let me tell you. Okay, we have 3 addresses over here. Let me tell you, or you can tell which class which address belongs to. 132 belongs from 1 to 127. No. Belongs to 127 to 192, 191. Yes, that means this is a class B address. It will have 2 slots for network and 2 for host H and H. So this is class B. This one, 127, no. 191, no. That means this is a class C address. So 3 slots for network and only 1 slot for host. And then you have this, which is way before 127, so 1 for network and all 3 for hosts, which is definitely class A, and this is class B. You can rewind the video and check the numbers for classes. So the most number of hosts will belong to any class A, of course, because it's giving you 8 into 8 in 255 into 255 into 255, which is a huge number. For this you will only get 256 addresses. For this you will get 256 into actually cube. Here you will only get 256, and here you will get 256 into 256, which is 256 whole square. So the most number of addresses you will get from class A and the least you will get from class C. And class B is in the middle, and that's how you do classful addressing. Now we already know IP address is a 32-bit address. They are unique, but privates can be used uniquely, and everything else we have done. Okay, it's actually the same slide, some problems and solutions. I'll go show you, and you can just pause the video and try it yourself. I'm just showing you. I'm not going to do it over here. Binary conversions, we have already done this. Okay, so you can see the address per class. Class A will give you a whole lot of addresses. Class B will give you less, but still whole lot. Class C is very low. Class D and E out of order, kinda. You can also figure out those addresses using the binary table, like I gave you over here. So class A will always have a 0 byte. Class B will have start with 10. Class C will start with 110. And you can test your skills with this. So 0 is the first one is class A, the second one is going to be class C, the third one is going to be class B, and the fourth one, a wild guess, class E. And you already know this range. I've did it. So you have some exercises over here. Just in 1 second you should solve this. And this is C, this is also C, this is A, this is E, and this is B. I hope I'm right. Yes, I am. So that's how you do this addressing. Net ID, host ID, we did this already. So now we need to come to a decision where we can solve the problem of using too many addresses or having shortage of addresses. So class A is giving you a huge number. I don't want that. And class C is too low. I don't want that either. Class B is medium. But that's still too high for me. So I need a little range which is more than class C and less than class B probably. What's the solution? Is there any way to divide a class? That's called classless addressing. That's what we will do, subnetting. So you have, before subnetting, it's very important to know the IP address and default mask. We did it at the start of our video, right? So with subnetting you can do stuff, and it is possible to have 192, where if you're using a class you will always get 255s. You will never get any number except 0 and 255 on your subnet mask, default mask, which is called default mask. Subnet mask actually suggests that you are doing subnetting. So in that way I can have this partial network address, where I was always supposed to get 2 network for class B, right? This is class B, and I'm expected to use 2 for network, but here I'm using 3 for network. Where else I'm using class B? This is called classless addressing. So that's what subnetting is. So like we did before, we can find out the network address of subnet by using the AND. We did this already, so I'm going to skip that. And actually there is nothing more to do over here. Here you can see some worked out examples. You can try this yourself and you can find out the network addresses. So we have done all things, and we completed this AND and finding the network address, subnet mask, and also the IP address. Use the binary method that I showed you, using that 128-0 table, and use that, and you can convert any address to binary, and do the AND of IP and network, and you will get the network address. IP and subnet, and you will get the network address. Okay folks, so that's all, and this is one slide I want to show you. This will be helpful if you do CIDR. You can memorize these numbers. This is only applicable for subnetting. If you subnet, you will get CIDRs which are not 8, 16 and 24. Subnetting CIDRs, these are all subnet CIDRs because you are using partial ones. You probably won't gonna get this. So there you have it. You can use this table to find out CIDRs of addresses if you need, and that's all. So I hope you benefited from finding the IP address, and there are lots of examples in the video. You can pause the video anytime and try it out. I have also provided the answers, so it will be pretty helpful, and I hope happy addressing guys, and also don't forget to survive. See ya.